Today, we are going to discuss the three topics that is covered on our semi-final period. So first, what are the types of clouds and precipitation? First of all, I'd like to say that learning these different types of clouds has made me appreciate the beauty of the skies. Upon understanding the hydrological cycle and how these clouds form, I've learned that they have functions and they have a big impact on the weather. There are three types of clouds and the other types are just combination of the three. To start, first is the stratus clouds. As what I have understood, they form layers, and these clouds may produce rain or snow, but not all the time. Some stratus clouds could also indicate fine weather. These clouds usually form when a mass of air is slowly pushed up over a mass of cooler air or over a mountain. Next is the cumulus clouds. These types of clouds are large bubbles of warm air rising rapidly into the atmosphere. They usually have flat bottoms and puffed tops. The bigger the puff of cumulus clouds, the greater chances it can produce great amount of precipitation since it has greater tendency to carry a lot of moisture. A variant of cumulus clouds is the cumulonimbus clouds. They are big cumulus clouds and they produce thunder showers. The third type of clouds is cirrus clouds. They are thin, light, and feathery type of clouds and they are usually formed on higher altitudes. They almost always indicate the fine weather. Moving on to the types of precipitation. First, we start the most common type of precipitation, which is rain, which is liquid droplets known as raindrops. It's one of the few precipitation types that can occur during any season. Next is snow. Snow is actually millions of tiny ice crystals that collect and form into flakes, which we know as snowflakes. Third is sleet. Sleet is small and round, which is why it's sometimes referred to as ice pellets. It makes an unmistakable sound when bouncing off the ground or your house. If a snowflake partially melts but then refreezes, you get sleet. Fourth is hail. Hail is often confused with sleet. Hail is 100% ice but is not necessarily a wintertime event. It usually falls only during thunderstorms. And the last one is graupel. If super cold water droplets freeze onto falling snowflakes, you get what's called graupel. There are also a lot of precipitation but there are just the common ones. Next, structure of depressions. For the structure of depressions, I have learned many things regarding the formation of tropical depressions and how they originate and develop into tropical storms that are destructive. First is knowing air mass. An air mass is basically a mass of air with uniform temperature and moisture content horizontally. These air masses have source origins. Source origins are areas of the globe where air masses originate. They occur on extreme latitudes. This is where the air masses obtain their temperature and humidity by sitting at that location. The humidity characteristic is derived on the type of surface. A source region can be on land or water. An air mass that sits over a water surface is called a maritime air mass, and an air mass that sits over a land surface is called a continental air mass. The second characteristic, which is temperature, is derived on the latitude of origin. They can be equatorial, tropical, polar, or arctic. Overall, an air mass is named on its humidity and temperature characteristic combined. The boundary between two entirely different air masses is called a front. A front can be warm or cold. A warm front is a transition where a warm air mass replaces a cold air mass. They move from southwest to northeast. A cold front is a transition zone where a cold air mass replaces a warm air mass. They move from northwest to southeast. Now, to discuss depression. First, we must know that depression is region of low atmospheric pressure. In a synoptic chart, a depression can be shown as a set of closed curved isobars. It is important that we monitor the pressure pattern by looking at the isobars. In that way, we can determine the locations with high or low atmospheric pressures. That includes looking out for the warm and cold fronts. Occluded fronts, which are basically just cold fronts that move past warm fronts, and rus, which indicates turbulent air. A depression develops through four stages. First is the origin and infancy stage. Second is the maturity stage. Third one is the occlusion stage. And the last one is death. Next, to the last topic, anticyclones. Anticyclones are basically the complete opposite of cyclones. They are regions with high atmospheric pressure. In subtropics, anticyclones persist there for a long period of time. That is why they are termed as permanent. While on the polar and temperate regions, the anticyclones there occur seasonally. Hence, the term semi-permanent. Anticyclones may either be warm or cold. Some anticyclones may show both warm and cold attributes. They mostly occur in the temperate zones during the winter months. In the central area of a cyclone, the airflow system is quite complicated. There is divergent of air flow near the surface and there is convergent of airflow in the upper part of the troposphere. And this phenomena is called subsidence.